Hello again. I'm going to take one last stab at trying to put my perspective forward here. I was going to present evidence and examples of papers and things along that nature that are against the current dogma of climate change. But there's all kinds of evidence on the internet. You can go and look at it yourself, and it appears that even though you bring such evidence forward, it's just ignored. Of course, that's dogma when you do that. So what I'm going to do is I'm going to focus on some logic, some other aspects of this whole debate. But first I want to make a statement that there was an error in the video that I did that showed the three documentaries. Climate of Fear was not put out by the BBC, and I apologize for that error, and I thank the individual for showing me that. The other thing is in my last video I made a statement that probably made your eyes roll or dropped your jaw when I said it, and that statement was that evidence cannot be wrong. Well, yeah, that's true. Evidence cannot be wrong. Evidence cannot be right either. What is right or wrong is the interpretation that we put on that evidence. And when we put interpretation on that evidence, we come up with our theories. And then we test those theories. Now, if you make it, there's two ways that theories can be tested. And the first way is an explicit test. In other words, you've got a theory and you make a prediction based on that theory and you test it. So if that test turns out to be correct and falls within your theory, then your interpretation of the original value A, for example, is correct. In other words, so you have evidence A, you put an interpretation on that evidence, you do a prediction based on that interpretation, and evidence B then supports the prediction that you made. Thus your interpretation of what A means must be correct. If, of course, you do the test and it turns out to be false, then your interpretation of A evidence is wrong. Hence you have to change that. The other way that evidence can be tested, or theories can be tested, is implicitly, and that is that somebody else does something somewhere else that is completely nothing to do with what you're researching or what your theory is, and comes up with evidence that contradicts or supports your interpretation of A. So they come up with C, and if C fits your interpretation of A, then your interpretation is correct. If C, on the other hand, doesn't fit your interpretation of A, then you're wrong. But that doesn't mean that A is wrong or right. A is just evidence. It has no right and no wrong. So that's what I meant when I made that claim. So now the logic of this situation with the climate change and everybody's hype and dogmatic positions of it. A little bit of a story here. When I was fighting creation science many years ago, I said to a physics teacher that, actually I think he was a physics professor, but at any rate, I said that biology was far more complicated a science than physics is. And ever will be. Physics is pretty straightforward. I mean, you come up with these equations of how the universe works and how particles work, and that's pretty easy when you do that. You got it, and it works, and there's very few particles that you have to worry about. There's very few forces in the world. Granted, it's not all figured out yet, but you're getting there. Hopefully the limitations won't be able to stop us from actually finding out. But at any rate, in biology, we've got at least 3 million species of organisms, not including the fossil record, that behave in all kinds of different ways. The permutations and combinations are essentially infinite. There's no mathematical formulas that actually tell us how a species is going to evolve. We can do tests, yes, but it's just far, far more complicated. But it's not the most complicated science, and it's not the hardest science, biology. The hardest science has got to be climatology. Because with climatology, you can't run tests like you can in biology. And in biology, we can take a population of organisms, throw them on an island, and see how they behave. So, and then you can change the parameters and throw a different population on there, or the same population, change the environment a little bit, and see how they behave. You can actually run that experiment, and that's actually what's going on in the Galapagos. But at any rate, you can actually run these experiments if you wanted to do so. You can't do that with climate. You can't reset the Earth's climate to such a point where, well, let's see if a hurricane comes about, or let's see what happens when we bring a cold front down from Canada and see if it sends off a bunch of tornadoes in Tennessee. And then we'll do a different temperature of cold front, and then a different temperature, and then we'll have it go in a different way. You can't run those experiments and reset the clock and try again. So climatology is based only on observations. You really can't do much testing. There's obviously laboratory testing that can go on for small scale stuff, but you can't do the types of experimentation where you can make predictions and then test those predictions. You have to wait to see what happens if your predictions come true. And there's a very good reason for this, and that is because climatology runs on chaos. Not the colloquial term for chaos, but the actual scientific term of chaos, which basically means that there's so many permutations, so many combinations, and input values can have such an eventual change and long-term effect that there's no way you can predict an outcome. So, and that is also referred to as the butterfly effect, that if a butterfly flaps its wings in China, it causes a hurricane in the Atlantic Ocean type thing. Not quite like that, but you can't take the butterfly and put it in New Zealand and have it do it and see if it does what it does and see if it produces the same hurricane. You can't do those kinds of experiments. Any kind of change in a parameter, even a tiny little change in parameter, will have a tremendous difference in the outcome. The climate models in the computer programs that they're running right now certainly are very complicated, but because chaos reigns supreme, there is no way it can be complete. It's physically impossible for these computer programs to be complete. They will always be adding more evidence because the number of combinations and permutations and the way the sun works and the way the climate works and the Earth's orbit and all of these things, humans involved in it, and not just CO2, but land changes and all kinds of other things that are going on that affect the climate. There's just no way it can be accurately modeled. So, what does that mean in this entire debate then? It means that you can't have a specific firm view. Because if you do have a specific firm view, chances are very likely you're going to be wrong. If you have a specific firm view and you ignore other evidence that doesn't fit your view, then you're dogmatic. And anybody who pretends to be science, but then at the same time ignores evidence over here that doesn't fit their dogmatic view of what the science said, they think the science says, then you are firmly in the camp of dogma. So I'm appealing to people, anybody who supports this doom and gloom, end of the world, end of civilization as we know it scenario for climate change. And I'm going to be specific on that. Climate change. Don't be so dogmatic about it. Just, you know, it's possible that it could be wrong. And in science, you have to maintain that possibility that it can be wrong. Because if you don't, you're just being dogmatic. And people like me are just going to keep hounding you for being dogmatic.